Jim, I'm going to have you go first. So I know you said you had a few things to share. I don't know if you want to go ahead
Yeah, let
and
me go ahead and
share.
try to bring that up. Sure.
Yeah.
Put this
You're good.
down. Okay. Oh, there's my hobby. Good thing we don't have that today, Heather.
Yeah, no. All right, you're good.
Okay, you can see it. Okay,
Yep.
let me make sure. Let me just get my screen set correctly. Okay. So let me talk about, I've got a few slides here I wanted to show from recent issues that I've seen at different clean room sites in the industry. And I just wanted to kind of highlight some of these because I see these things often. And then I'm going to, well, I'll turn it back over to Heather, but I think Morgan will probably go next here. So one of the things I've seen a lot in the industry is with the ventilation systems, when you've got the HEPA filters and the HEPA is coming either down from the ceiling or it's coming in horizontally, is a lot of times I've seen incorrect placement of the air returns. The other thing I've seen with a lot of the air returns is they just don't ever seem to get cleaned correctly. So as you can see here on this air return, it's got a lot of dust on it. It's also got a lot of caulking that it just does not, pardon me, getting over a cold here. It appears that it's got a lot of caulking on it here that is seeping out from underneath the ventilation vent. And that's a problem in the industry because this caulking flaking off at the bottom will become a particulate issue in the clean room. And the same is true with this dust gathering on top of it. That can potentially be a bioburden or particulate issue in the clean room. So when you do have a shutdown, my recommendation would be to go in and fix the caulking problems and certainly clean around these ventilation filters. And the reason being, if you don't, I think that potentially it can become a source of particles in the room, maybe even a source of mold in the room. And I've even seen in some instances in the clean room where uh, they don't, routine maintenance doesn't take place. And for example, in the lighting fixtures in the room, I'll actually see mold spore growth, black mold, growing in the lighting fixtures because they don't routinely go in and replace the light bulbs or take care of that and clean around that on a routine basis. So another thing that I see here is the ceiling uh, and when sealants are applied in the clean room. And here is an example where a sealant was applied to a ceiling tile. And as you can see here, the sealant is it basically looks like it's almost leaking from that area. It's not applied correctly, and thus it's creating, a particle and potential bioburden hazard in the room. So that's another problem that I see that really should be fixed when you do have a shutdown. And a third thing I want to mention on this slide, and then I've got a couple more slides. A third thing is the tacky mats. So when I go into the clean room site, and I'm sure Morgan has seen this too, and a tacky mat looks dirty, and I ask the question, how often do you guys clean your tacky mats? And then I get like a deer in the headlights look, like, what do you mean? Well, if you call Dyson or the tacky mat manufacturers, they're going to have a recommended frequency to clean these mats because as you can see here, they get very dirty. And recently at a cell and gene therapy site in New England, an ATMP site, they had a big outbreak of Aspergillus mold. Well, one of the potential root causes is they never clean the tacky mats. And as you can see here, it's got a lot of particles and potential even bioburden on it. So that does need to be periodically cleaned. And if these are the kind of tacky mats that you can just peel off and then you'll have a new one behind it, so almost like a crack and peel tacky mat that are disposable, uh, then you need to make sure you do that on some routine basis so that when it does get dirty, that you're changing it out. So any comments or questions about these things that I see periodically in the clean room?
I have a couple comments, Jim, if I can share or kind of expand on what you were talking about, if that's all right,
Yeah,
or
sure.
you
Go
want.
ahead. You want me to pull down
Yeah.
here? I
So
can pull down the slides if you want to bring something
no,
up.
leave the slide up. Leave the slide up. Leave the slide up if that's all right.
Okay.
Yeah. So like Jim was saying, talking about ventilation, air returns, being in the right place or the wrong place, talking about design. One of the things I was going to add to the panel discussion was often the placement of air returns or HEPA filters themselves aren't considered as part of the design. Often in terms of the movement, the flow of personnel or equipment, where you place the air returns. Sometimes I see a lot of times air returns will be blocked. People design a room and it's not really purpose built, so they put equipment in there, kind of an afterthought, and air returns gets blocked. But to Jim's point on the air returns, if you're a medical product cleaner and you've got dust, doesn't matter if it's your ISO class 8, your grade D. If you got dust, you've got a problem. You have a problem. And kind of expanding upon that, one of the common things I see, and I see it really, really frequently, I'm in a lot of clean rooms, is what Jim was talking about, the caulking. A lot of times the caulking in pharmaceutical facilities, septic facilities, is always breaking down. And one thing about caulking, and not to be specific, but the type of caulking you use needs to be specifically for the type of industry your products. For example, if your very common type of caulking material used in pharmaceutical clean rooms is silicone, RTV is often a trade name, often used. Silicone, it's very commonly used. You couldn't use, or you should not use, a silicone caulking or sealant in a electronics facility, optical facility, or a aerospace facility, because it outgasses, and that outgassing can lead to condensable organics on surfaces. In fact, it has been an issue at multiple electronics facilities, and came down to caulking, wrong type of caulking. And if it's breaking down, that's also a problem. And just to agree with what Jim was saying about tacky mats, right? Not just having them, but they need to be deployed in correct locations. And also, the strip off, the disposable tacky mats, you don't rip them off. It's more important to understand. You have to roll them up, and something that people don't necessarily understand. That's what I wanted to add.
Hey, excellent. Thanks, Morgan. Anybody have anything else they wanted to mention here before I go to the next slide? Oh, go ahead. Go ahead.
Yeah, Veronica.
Yeah, hi, thanks. So with regard to the tacky mats, right? So those Dyson ones, they do have the end of life. So what have you seen typically from manufacturing? Like how often should they be replaced? Not just cleaned, but replaced, because that's what I've seen sometimes. They get to the point where they're shedding. It's obvious they got to go, right? They need to be replaced. But then the input sometimes from the manufacturing, they're looking at me saying, you're crazy, right? Nope, we're cleaning them, we're good, right? So they're kind of missing that point that, no, at some point they need to be replaced as well.
Yeah, Morgan, you might have more of an opinion on
Sure.
that. My guess would be every year, maybe?
So we're talking the Dyson, we're talking about the polymeric flooring. I know it all depends on how well you take care of it. So, I mean, different companies, so there's Dyson, there's Tech Track, there's Polyflow. There's several different manufacturers, with Dyson being one of the first companies to deploy it. But it's typically referred to as polymeric or clean room flooring. And I know companies that have had effective installations that have lasted up to 10 years. It comes down to the foot traffic and how you clean the mats, right? So the end of life, the manufacturers they're going to tell you, they might tell you something, oh, we recommend you replace it X number of years. It depends on how much it gets used and what you're rolling over. If you have a Dyson or Dyson flooring in a high traffic area with a lot of carts and scissor lifts or forklifts, you might find that you have to change it. The reason you would change the Dyson, a polymeric floor, is if it loses its tackiness. So if you take care of it, if you clean it on a regular basis, and that basis is going to be based upon traffic and usage, right? You clean it with the right materials, it can last for years. So what's going to determine how often you will replace the polymeric flooring is going to depend on those factors. And like I said, I've had companies that have used them up to 10 years and not replace them, they still retain the tackiness. Does that help answer your question?
Yes, thank you so much.
Anybody have anything else before we move on? All right, I'll go to the next slide. Let me here highlight this. So this, these are three issues that I see quite a bit when I go to different biopharma or medical device manufacturing sites. One is up in the ceiling area. I can't tell you how many times I've seen facilities where I look along the lattice structure up there, maybe in around the where they have the HEPA filters in, and I'll see all this black, up in that area, and that is typically black mold. So that is Aspergillus, Stachybotrys, and it does need to be cleaned routinely. So as part of your routine cleaning program, whether it's monthly or quarterly, you should be going up and cleaning around the ceiling. And certainly on these joists here, if you do see mold growth, that may even, you may need to get up there and clean it. And if you can't get rid of it, you either may need to get a mold remediator, or you may even need to look at replacing that. I've actually worked recently with a site, and I'm going to mention it in a few minutes, where they had such a mold outbreak that they actually had to throw away some of the furniture in the room because they just couldn't get rid of all the penicillium from a water leak in the interstitial space above the ceiling. And another thing here, and I'm sure that probably Morgan and I can talk about this the rest of the day, are cartwheels. So Anne Marie and I love to talk about cartwheels as well. Whenever you're taking either a cart or let's say you've got a media tank and it's on wheels, or even a mop bucket system and it's on cart wheels, those wheels need to be cleaned periodically and decontaminated with a sporicide. When the wheel starts to look like this and you're seeing kind of a breakdown of the caster and the wheel itself and corrosion and buildup of residue, if you can't get the residue off with the cleaner or disinfectant, and you see that it is really corroding, then you may actually need to look at either replacing the wheel and the caster or even, potentially replacing the cart itself. Because you really don't want a wheel like this or a cart system like this, floating around the clean room on a routine basis. And the other big thing that I see a lot, and I'm sure that even Morgan talk about this, is with the new CCS, contamination control strategy, pushed out by the revision of Annex 1 in August of 2022, one of the key things that's part of CCS is a pest control program. So you'll notice here, we captured a spider in a clean room, but I've actually been in a clean room in Georgia where they routinely capture snakes. So whether it's a snake, a spider, or even a few years ago, I was at a clean room site, they kept getting hits in the clean room by a canine bioburden. We looked at the videotape, and about 2 o'clock in the morning, the security guard gowns up and he goes walking through the clean room with his German Shepherd. So all of these are definitely potential contamination issues in the room and a contamination control issue. And, you certainly want to have a good pest control program that's updated, and routinely you want to make sure that you go in and continuous improvement of that program so we don't have little creepy crawlies walking around the room. The same is true here with the cartwheels. If you do need a replacement, I've been to one of the big pharmaceutical sites that makes injectables in the Midwest, and they use so much bleach at a very high concentration as a sporicide on their tables and carts that it actually corrodes the stainless steel. So if that's true and it gets to such a bad level, you don't have many options other than to really replace the wheels and replace the cart, because you really don't want to be wheeling that around the facility and creating a particle issue or even, potential bioburden issue. And then like I said back here, if you see black mold growing around the ceiling structure or around anything, that's above you in the clean room, that really does need to be addressed. And whether you go up there with a bleach or a different sporicide, you need to do it on a routine basis because there is a high risk here of additional contamination coming down into the room. So Morgan, I don't know if you want to add anything. Feel free
Sure.
to.
Yeah. Oh, that's a great subject. I had to add on fungal contamination. I can't tell from the picture, but it almost looks to me like it looks like there might have been an adhesive, like a diffuser or something like that, used to hold it up. But one of the things that's real common is adhesives and any type of tape. And in a set, so Jim had mentioned a couple of things. He mentioned fungal contamination, use of bleach, and also pest control and CCS. And that we're talking about terms, particularly Annex 1. We're talking about the concerns in life science, particularly in sterile medicinal products. If you're an electronics manufacturer, if you're making optics aerospace, you don't really care about fungal contamination. You care about cleanliness. You care about particles. And a CCS it's a good idea, may not be a term you're formerly used to. But fungal contamination is a really big deal. And Jim, you mentioned the case study of the customer having problem with a leak in their interstitial. That's very, very common. I see it in medical product clean rooms all the time in the US and abroad. It's just not really well understood. So you really want, if you start to see mold growing above your clean room, above your work area, you need to shut it down. And one thing I like to say, if you're a medical product company and if you have a leak in your interstitial, you need to treat that as serious as a fire. Right? If you got a leak and you got a leak in your building, you're making medical products, you need to shut down and fix the problem. You need to take it every bit as serious as the fire, because you are going to have problems, and those problems lead to increased risk to patients' health. And I completely agree with cartwheels. Foot and wheel-borne contamination. I like to talk about contamination control. The ground game is extremely important. You know, how you clean your floors, the type of wheels you have, and really choosing the right materials. And your wheels should be inspected. And the biggest problem when it comes to wheels and carts and things like that, nobody really knows how to clean them. I see people, doing all kinds of different ways of cleaning. One company, would suggest what we do. We don't clean our wheels. What we do is we put clean room tape on our wheels, and then we just change the clean room tape. That's a terrible idea. The terrible idea, particularly in a medical product clean room, because fungal contamination, fungus, mold loves adhesive. It's a big deal. And if you've got if you've got adhesive, you're going to have mold, and the clean room tape is going to be a source of that. And of course, pest control is really, really important. I got all kinds of stories. I did some work for NASA out of the White Sands Test Center, and they have a problem where about every couple of months they've got rattlesnakes in their ISO 7 clean rooms. And the problem is the pest control doesn't work for them because the snakes are they can flatten out and get between the cracks, and it's always something to keep in check. So yeah, really good slides. Anybody have any questions? Anybody have any issues with pests at all?
And feel free to go ahead and unmute if you need to.
Well, one thing I want to mention, Morgan, going back to the cartwheels, just a couple of things that I've seen for ways people decontaminate them. I know when Anne-Marie teaches the cleaning disinfection course at IEST, she puts a sporicidal wipe on the floor and then takes the wheel and goes across it from one classification to the other. So I've seen that technique employed. I've seen where operators spray the wheel 360 degrees, or they wipe it with a sporicidal wipe. That's probably okay. And I've even seen a site up in Pennsylvania where they have troughs in the clean room, and the wheels sit in the trough in the pass-through for 15 to 20 minutes, immersed in sporicide before they bring it into a classified area.
Yeah, I worked with an electronics company that would remove the car wheels on a yearly basis, ultrasonicate them, and reinstall them. And that removes all the particles. And again, they weren't concerned with fungal contamination, but the wheels were clean. And one thing to look at, I mean, it's something, I do a lot of contamination investigations, and one of the things I always look for, part of the investigation, is the shape of the wheels on the floor. Good points.
All right, I just have a couple more slides here. Anybody have any questions or comments before I move? No? All right. Let me. So this is a case study from Austria, and this was at the beginning of the year. This is where I mentioned that they had a big mold issue because of a leak from the technical area. So in the box in yellow is where we're of concern here in the clean room, because this is the room that was affected the most by the mold contamination. So here we had a cutting instrument where they're making patches that go on to people when they're having operations on the skin. So this is the medical device that they're making here. Over in this section here, they do some testing, and there's a lot of furniture, chairs, and tables here, and most of which that after this leak had to be basically thrown out because of the mold concentrations. So in the technical area above the clean room here, when clean rooms get to be around 20 years old, you start to have more and more issues with them from a manufacturing perspective and technical perspective. So the issue was up above the clean room over a weekend. They had this valve here on a pipe above the clean room that broke, and it put about 2 to 3 inches of water from the ceiling into the room. So thus you had all these ceiling tiles here that have inside of each of these tiles, it basically has like a, I don't know if you want to call it a red or yellow insulation material, and it all got wet as well. So we, basically flooded the room with water, which is a great source for mold. And then we have water up in this interstitial space technical area above the clean room. So one of the things we did recommend, and here's kind of up above that area with all the piping, we did recommend to go into this area after the leak was sealed and after the pipe, was sealed, and do a VHP cycle and cordon off the area and use VHP in here. We thought that may help reduce the risk, of another mold contamination. But one of the things I see here a lot, and Morgan I know can speak to this, is people don't go up into these technical areas and periodically check things to see, do we have a bad pipe in the area? Do we have a bad connection? What is the risk level of a pipe breaking? So that is essentially what happened in the room. And as a result, we had very high levels of both of these strains of penicillium. We also had another mold called Neurosporia, and then a Bacillus pumilus. But these molds in particular were at very high levels from the water contamination, and the root cause was this water leak in the room that, of course, they fixed. They brought me over as a consultant because that's some of the things I do, work a lot with mold, just like Ziva does. And I took a look at everything, and for about a period of 6 weeks from this, technical zone, once they took care of this, pipe, and sealed everything off, dried off the insulation, took as much insulation that was wet out that they could. I kind of felt they had no more hits of mold, so all these 3 molds tend to disappear for about 6 weeks straight. So when I did my write-up, I basically said that I think the risk is very low, that we're going to have another contamination with these specific molds due to a water contamination in the room. But I couldn't really say the risk is 0, because as I said, when we're looking at clean room sites that are 20 plus years old, there's some degree of risk there, and the risk isn't 0. So anybody have any comments about this case study here?
I would add one of the things like, yeah.
Oh, go ahead.
One of the things about the interstitial leak, right, is if you have ceiling tiles that got wet and you didn't replace them, you're going to have problems down the road. All the insulation around the pipes, if that got wet, material in there can harbor dust and mold and these things, and I think it's always coming back. So, like I said, water leak is a very serious problem, and you gotta really remediate it. You gotta get rid of anything that's wet. I see sheetrock in the building, on the walls there, that type of stuff can still harbor And the problem is, it can come back and bite you. I have a story I can tell a little bit later about a company that had recurring fungal contamination problems due to the same type of leak.
Yeah, and these are big issues because one of the problems is in this paneling. Morgan, you couldn't get all of the insulation out. It was just impossible. You got maybe 90%, 85%. So there was some of it that still remained in there.
Yeah, and that's and talking about building design, right? So design, we're talking about things to avoid designing a clean room. You got to make it so you can service. Got to be serviceable. And ceiling tiles, HEPA filters, all those things got to be serviceable. And you got to think of that stuff up front. Because at some point, something's going to break and you got to be able to get it out.
And you got to be able to get in there. That's the other thing.
Yeah, absolutely.
Because I got to be honest, when they brought me on site, my colleague had to go in there because I couldn't fit in there. This is a very small, almost like crawl space up there.
Yeah. Probably people who haven't been up there since they qualified the room. Maybe occasionally for a PM or something, but yeah.
Yep, that'd be my guess. Any comments or anybody have anything they want to add? Well, I'm going to go ahead and stop here, Morgan. I want to make sure to give you time. I have one more on mold.
Oh, go ahead. Why don't you go through it?
Well, I got to find it real quick. So why don't you go ahead and start?
Yeah. All right, cool. So I didn't have any slides necessarily prepared, but I definitely have case histories. And to kind of expand a little bit what Jim was saying, things not to do, the topic of this is, cleaner design, things not to do in your cleaner. And a couple things is, number one thing, and it's a pet peeve of mine, it's a very common thing I like to talk about, do not put air returns in the ceiling. Okay, there are exceptions to that, and depending on the type of facility, but generally most clean rooms, in fact, I might have a slide. Most clean rooms, you don't want to do it. It's just a bad design. The reason it's a bad design is we typically like to pump clean air in at the top and suck out dirty air at the bottom. That's why we have low wall returns. And the advantage of that aspect is particles. The particles that generally would be carrying microbes are going to be larger, right? And large particles do not flow well in air. It's an issue with particle counting, an issue with removing and cleaning up our rooms. It's also an issue, a difference between US GMP and international GMP when talking about larger particles. And putting air returns in the ceiling can create short circuits where air, instead of flowing and mixing with the room in non-unidirectional flow rooms, it short circuits and we have less of effective mixing. And I've seen this countless times. In addition to that, it has been flagged by the FDA. I have numerous 483s and even warning letters addressing air returns in the ceilings in medical product clean rooms. And it's not good contamination control. And it's something that you see used to be very, very popular in electronics facilities, particularly back-end facilities in electronics, even hard drive manufacturing, optical manufacturing, but it's just not a very good contamination control practice. And again, from a pharmaceutical standpoint, the US FDA has written 43s and even attached warning letters attached to the design flaw. Another common misunderstanding or thing is that people not designing their clean rooms for the type of products that they're going to be manufacturing. And this is a universal problem across many different industries. It's very important when you design your clean room to think about and understand your workflow, to understand your material flow, to understand locations of operators and equipment, and have that in your clean room design as you go to design the clean room. Can't stress that enough. I see a lot of times facilities where companies will say, okay, we need an ISO class 7 clean room with ISO class 5 work areas, and they're going to be over here. And not a lot of thoughts put into where we place those, the equipment or furniture. And then we'll run into locations where equipment will block air returns, or we'll place inspection stations or areas that need to be very clean directly in front of an air return. And the thing about air returns, very important to understand, an air return job is to return air back to the air handling system or to exhaust air of the clean room. And that air that's coming to the return is going to be highly concentrated in particles. So there are particles in the room, those particles are going to be drawn towards the air return. So we don't want to put anything we intend to be clean in front of an air return. And that's something we really have to think about in a design of our cleaner. Where are our air returns? Where are our equipment? What's our movement? And I've seen multiple times where that's been an actual cause of intermittent contamination problems. And one thing I also would like to expand a little bit upon what Jim was saying before about fungal contamination is we have to understand that we have to have suitable material compatibility. And Jim mentioned people using bleach, right? I've seen bleach used so much that it has destroyed the flooring. Right, this was a pharmaceutical facility, a company making Botox in South Korea, and they wanted to be able to ship their products to the U.S. and they couldn't because their facility was in such bad shape. They had fungal contamination issues, and the way they addressed fungal contamination issues were simply to use bleach. And it's one of the things that when you go and you're in a facility, you're walking in a pharmaceutical facility, you know, whatever I'm there for, I'm always looking because it's I guess I had AHAD. Right, I can't stop looking. I can't turn off my contamination control engineer. And if I start to see rust on stainless steel, I start to see discoloration of flooring or wall for things like that. It always is a flag to me, like, oh, I think you probably have a fungal contamination issue. And then people will be like, how do you know that? We didn't mention that. Well, I think you're using a lot of bleach because of the corrosion, because of the discoloration. Well, we are, and we have. And it turns out, sure enough, they are. So it's really important. And the story I wanted to tell, case study I wanted to share, was this was a medical device manufacturer in Tijuana, Mexico, just across the border from San Diego. And they were having intermittent large particle excursions. And what had happened was, Annex 1 had changed. They're suddenly required to start looking at 5-micron particles. And they were having intermittent excursions where their 5-micron particles were out of specification. And so we came doing a walkthrough, and we're walking through the facility. It's a medical device manufacturer. They're making everything from stents to catheters to drug device kind of combination products, including aseptic filling of these drug device products. We're walking through the facility, and it's a lot of things I saw. A lot of things I saw. One, they laundered their own garments. They did it in an uncontrolled space. They had a printer in the ISO 7 clean room. These are things which are problematic, but that wasn't the cause. In my mind, it wasn't the cause of their intermittent problems. And different things, mop buckets and other things. But when we're walking through, and I started to notice the light fixtures in the ceiling, quite a lot of them would have a little bit of rust on the edges of the light fixture. And I asked them, what's the deal with that rust around the light fixture? And they're like, oh, well, when it rains, we're in Tijuana, and when it rains here, it doesn't rain often, but when it does, we got to put buckets up. That was the reason they were having intermittent 5-micron particles. And we went back and looked at the data and the weather charts, and it would rain. And 3 or 4 days later, the 5-micron particles would be out of control. And then it would dry up after 2 or 3 days. The problem would magically start to decline to be a point where they're back in control because the moisture went away, the mold species went into hibernation, was no longer active, recruiting spores, and just waited to the next time it had more water. So again, and they had to rip out their entire ceiling to address the issue. They tried a bunch of different things. They tried to go out. They tried to use hydrogen peroxide vapor to address the issue. But the problem came down. They had the damage. They had to remediate it all. And then they could work their way back. And that's just an important thing to consider. Any questions so far on what I was talking about? Anybody?
Some great examples, Morgan.
Okay. Cool. So understanding the requirements of your product, very important. Understand what your products are and what contamination can be. And it's important to understand, if I'm designing a product for medical product cleanrooms, I want to make sure I design the product for medical product cleanrooms. I'm designing a product for electronics, I want to design it for electronics. And it's important to understand that, and really important, the people that you hire to do this, the people to build it and certify it, classify it, all the consultants you have, you want to make sure they have experience in that particular field. Because I have seen issues where people in the semiconductor industry design pharmaceutical clean rooms. And that's been problematic because they use their old adages that they learned from a different industry and apply it to the pharmaceutical industry. And sometimes it doesn't match up very well. Another case, an example is here's a story: a medical product company, medical device manufacturer making heart valves. And the heart valve, the way heart valve is it's typically a Teflon lattice. It's a substrate. It's made out of Teflon, PTFE, and the PTFE mesh that they sew on either bovine or pork tissue, pig tissue to create the valve. And the problem with PTFE or Teflon is it has electrostatic properties that cause it to be charged. In fact, it is an insulator, and it's a great source of electrostatic charge. And because they didn't take that into consideration when they built their clean room, they had all kinds of issues with electrostatic charge, and the Teflon particles from the manufacturing process was sticking to the heart valve. And they very difficult to remove, causing them to do a lot of rework and a lot of rejection. And they realized, hey, it's a problem with electrostatics. Well, instead of addressing the electrostatics from a core standpoint in the design, they decided to put in ionization. And they spent millions of dollars across multiple facilities putting ionization, but they put in the wrong type of ionization. The type of ionization they put in was ineffective at removing the charge on the products. And they struggled with this problem for years, and they never really addressed it. And again, if you have a problem with the statics, you got to start with your floor. You got a problem with the statics, you got to start with your materials. And ionization is the last thing you put in. You just don't band-aid and throw an ionization of the problem without understanding the nature of the issue. Anybody out there deal with any type of electrostatics in their facility? Electrostatic charge, electrostatic attraction, electrostatic discharge in their clean rooms? Anybody?
Yes.
Good. So what type of products do you make?
We have heart valves. We have some different medical devices that have electrostatic ESD properties. Yep.
Yeah. So in order to control electrostatics, you really have to have a electrostatic program in place. Putting ionization willy-nilly, particularly room-based ionization, this is a problem that I've seen heart valve manufacturers specifically challenged with, because they didn't have apply the right science. And the problem is the companies that sell the ionization and all that, they just want to sell you equipment. They're not necessarily there to help you solve the problem. And that's a sad case. That is a sad case, because I've seen medical device companies spend a lot of money on electrostatics without really having a really good plan, and really talking to the right people to help them make the right purchases and implementation of that. And particularly, like I said, if you're making heart valves and dealing with PTFE, you got to remove that charge, and you're not going to do it with a room system. And a blowgun may not be the best situation either. So important things
typically,
to consider.
The install of those ionizations or deionizers, they consider it as the first line of defense.
No, they're not deionizers. Yep. They're not deionizers. I'm sorry.
Yep.
That's the biggest problem. Number one, when people start saying, we put in deionizers, they don't know what they're talking about.
Yep.
We deionize water. We add ions to the air to remove charge. And that's a big mistake. One company, and they can't name the company, but they kept referring to deionizers, and they spent millions of dollars, and it didn't fix the problem. In fact, they put ionizers over the doors entering the clean room. They had ionizers over the door. You enter the door, people would walk underneath these ionizers to go into the gown room, and from the gown room into the process. And what was the purpose of that? Well, to reduce the charge on the person. Okay, but is the person making the product? Is the person the product? No, you want to remove the charge from the product, particularly in that situation where it's electrostatic attraction. Excellent. Another point is, another thing I'd like to talk about is other things you should avoid, definitely avoid the use of, don't put a pass-through in a gowning room. This is something I was at a 503B facility who actually was closed down by the U.S. Department of Justice. And they had multiple issues. But one of the issues that struck me was just an brazenly not a good contamination control aspect was using a gowning room where people are putting on gowns and taking off gowns to use as a pass-through for material entrance into the clean room. And the reason that's a problem is a gowning room is going to be a room that is designed to help control contamination, but its sources, when we're using a gowning room, when people are putting on garments, and more so when they're taking off garments, are generating a lot of contamination in the terms of particles and microbial contamination. And that's not a good entry for materials into your processing zone. So another point I'd like to talk about, prevention as well. Let's see, what else? Yeah, I talked about understanding requirements of your product. But another thing in talking about building our clean rooms is again, going back to design the clean room for the purpose, what it's meant for. I can't stress that enough. A lot of times also clean rooms can be too small. Go ahead, Trent or Veronica.
Yeah, sorry, I just wanted to ask about the pass-throughs, but we could wait, until the Q&A, but so just let me know if you want me to ask about the pass-throughs now or later.
Go ahead and ask right now. This is meant to be a panel discussion, so you ask your questions now, as they come up.
With regard to the pass-throughs, right? So typically when the new clean rooms are built nowadays, it's more common to install those interlocks where one door is closed, right? And controlled automatically. When you open one door, the opposite door is automatically locked. But the challenge with some of the super old rooms, right? When some of those interlocks were built, there's not necessarily that automated control, right? So they do have the interlock, but the doors are manually controlled. So what are some of the options or examples that you've seen to overcome that besides implementing the automated control? And I do understand, that implementing the automated control for interlocks is the best way to go, but getting the pushback from the sites, and I don't like the phrase, but we've always done it, right? Why do you want us to change now? So just looking for some examples there. Yep.
Sure, absolutely. So pass-throughs are something I have a couple pet peeves or triggers, right? I'm in a lot of clean rooms, and in pass-throughs and pass-through design implementation is something I walk by all the time, and I'm a user, so I'm always very critical of it. So let's talk the whole idea of the pass-through, right? Is to act as an airlock. A pass-through is an airlock. That's the purpose, right? So one door. So the whole idea is let's say I have an ISO class 7 room over here, and I have an ISO 5 room over here, or a grade C room and a grade B room here, and I have this pass-through going between them. The whole idea is I don't want to have an opening where air can go from the dirty room into the clean room, right? From the dirtier room into the clean room. It's meant to be an airlock. So the reason we have the interlocks is so that only one door can be open. So there's a lot of ways to do the interlocks. The interlocks, the most common way is a mechanical interlock where you got to turn a valve or only one door can be open at a time. Most of those can typically be defeated. There's ways people can get around. I see all the time. Now, if you look at GMP Annex 1, GMP Annex 1 spells out the criteria for pass-throughs, and this where it tells us, or airlocks. An airlock should be designed that there is a mechanical or some type of interlock to prevent. It's required between grade B or grade C and grade B and grade B and grade A that we have a mechanical interlock that can't be defective. There's other ways to do it based upon time, where you can simply have a timer. You can write your SOPs saying that this pass-through can be only opened, after it's been after 10 minutes. Let's say a common thing that people do a lot in the US would be to put something in a pass-through, to spray it down with spore cleanse, and it's got to sit for 10 minutes before they take it out. right? You have some type of timing circuit that's often implemented. If it's a GMP issue, you know, if you were in a GMP facility and you didn't have interlocks, you would probably be facing with an issue where you have a possible 483 for it. Well, not this is from the FDA, but the equivalent observation from an international regulator per Annex 1. So if you don't have a mechanical interlock, you should. I mean, you should. Ideally, if you can't, you can do a timer. And there's things you could do. You could just have a little timing circuit, put a switch in there. These type of things could be done without necessarily replacing the entire pass-through. But end of the day, you know, looking forward, new builds, I would definitely go with a more advanced pass-through. And in addition to that, an active pass-through is definitely preferred from a GMP standpoint. But an active pass-through, what I mean is it has a HEPA filter and or some way that clean air will effectively flush the pass-through. And that's mentioned in GMP regarding airlocks. Did that answer your question?
Thank you. Yes.
Okay. Any other questions? I had a couple more points I'd like to make. All right, cool. Another thing would be perforated tables. The use of perforated tables in clean rooms used to be all the rage in the 80s and 90s. And perforated tables can be quite effective in unidirectional flow situations. But in non-unidirectional flow clean rooms, particularly medical product clean rooms, perforated tabletops are problematic. And the whole idea, and I get a lot of pushback about that, and I'm okay with that because I've had to deal with this problem. The problem with perforated tables is, well, the design of a perforated table is meant to allow air to flow through the table. Doesn't disturb first air, doesn't disturb unidirectional air, or use the alt-dated term laminar flow, right? But the problem is, if it's in a not, I have to have a certain amount of air to be able to flow, to force energy to flow through those holes. And I rarely have that unless the HEPA filter is directly over that and typically within 4 feet and running at greater than 90 feet per minute. If I don't have that condition, then I don't have air flowing through those holes. And in a non-unidirectional flow clean room, I do not have forced air flowing through those holes. So the problem is now I have the surface, which has all these perforations. I have to clean each of those holes, particularly medical product facilities. In addition to that, I can have a situation where I can have air flowing from the floor up through the holes. And this depends on a lot of factors, particularly the type of clean room you have. It's more of a problem in America because a lot of American non-unidirectional flow clean rooms in medical product do not have circular, swirl, or square diffusers. So what they have is no diffuser, and the air comes down at 90 feet per minute, hits the floor, and we get this bounce effect, which can cause air to move upwards through the clean room as it's mixing. And that has been the source of more than one contamination problems among people I've had to deal with. Any other questions?
Jim, Morgan, do you have anything else to share, or does Jim want to finish up his?
Jim, you want to go ahead and finish up?
Yeah, sure. I just had a
points?
couple of slides here at the end.
Okay.
Let me bring it up here. Oh, tornado again. Hopefully everybody can see my slides.
Was that a double tornado or is that just one tornado? I mean, it looked like.
Yeah, no, it was what do you call it? It was twin EF4 tornadoes up in Nebraska. So that would highly be regarded as not a good day.
Yeah.
All right, so this is the EM data. I was brought into a site right at the end of the pandemic where they had a lot of site contamination from mold. It was an ATMP, which is cell and gene therapy clean room site up in New England, and it was fairly new. But this, when they showed me, you know, the hits they've had, which are up here on the slide, they had a lot of aspergillus, and especially in their BSC hood, which is where they do the manipulation of the cells that go back into either a single patient's body or multiple patients, whether it's allogeneic or autologous cell and gene therapy. So we took a look at the data over time, and they were consistently exceeding alert and action limits with the mold hits in the room. So I came in and I wanted to take a closer look at this with them. And I was actually there with a consultant colleague of mine as well from the industry. And one of the things I noticed right off the bat is going back to our tachymat example. The tachymats were completely black, had never been changed or cleaned. And that brings back that example that Morgan and I were talking about, where you should contact DISM or the tachymat manufacturer. They will have a cleaning process, and you really do need to do that on a routine basis. Otherwise, your tachymat's not going to have a very long half-life. The other thing was the mop heads they were using to clean and disinfect the floors were all pitch black. So they were loaded up with either mold or bioburden, and certainly you shouldn't be mopping the floors with black water. That's something I see when I go to McDonald's, because that's not really cleaning anything. The water they were using for rinsing and residue removal was water from the sink, so tap water. They had the wrong dilution of disinfectant and sporicide they were using in the clean room. And the only thing they were using to decontaminate the BSC hood was 70% isopropanol, which has limited efficacy against mold. So there were at least somewhere between 5 and 10 factors that we felt that they need to really do increased investigations on to find the possible root cause of all that mold that I just showed you. So one of the things I always recommend when you do that is do one of these Ashikawa or fishbone diagrams and isolate each specific thing. So people, method, measurement, materials, environment, machine, and drill down on each one of them. Then the next thing that I always recommend is either to do what I call the 5 whys. It's also sometimes called the 6S or 5S. So you can make a problem statement such as the wrong dilutions of disinfectant and sporicide are used. Well, why is that happening? Well, they don't have any disinfectant coupon studies. They lack the testing ability to be able to do this at a contract lab. They lack the financial ability. Another key thing, they don't have a site SME, subject matter expert in microbiology. So if that's the case, you may need to look at off-sourcing this to a consultant to come in and actually, monitor your program and either work this out internally at your site with your lab, or look at doing this to a third party and trying to find something that's within your budget. But the point I'm making here is anytime you have a big contamination event, you need to look at everything in the clean room. So it's not just the build of the clean room, but it's everything that is part of that clean room as potential sources. Because if you don't, just the smallest thing. So one site was using a black Sharpie marker to write on things in the clean room, and lo and behold, the tip of the Sharpie marker was contaminated with aspergillus, and thus contaminated everything in the room. So anyone have any questions here at the end? And Morgan, if you want to add anything, please go ahead.
Yeah, I got one more point. One more talking about things you got to look at when you're looking for a contamination problem. You got to look at everything. I was doing a smoke study at an eye drop manufacturer, big eye drop manufacturer. Can't say, I'm not going to say where it was, but they make a lot of eye drops, over-the-counter eye drops. And we're doing the smoke study on the rooms, and it's during the shutdown. And I just happened to watch, the team go around and they're starting to clean. And I happened to walk past the mop buckets, and the mop buckets had a black layer of soot on the bottom of the mop buckets. And I'm like, what the, executive, I was, I'm sometimes not pretty quick. I was very excited about what the heck. And I noticed, and I walked around, and 25 mop buckets that I was able to look at in that facility, the largest septic manufacturing of eye drops, a septic, right? All of the buckets have this black goo. And I went ballistic. I made it a point to contact the site head. I had people come in and I said, this is a problem. This is a big problem. This would get you shut. This would be an observation and a very serious observation. And they kind of hemmed and hawed. The lady responsible for cleaning said, yeah, I've only been here 3 months. I noticed that I was going to get bucket liners. And I snapped. I said, bucket liners. You could fix this problem today. You could go around, collect all the mop buckets, clean them, and then you could actually start replacing them. But you could take care of it today. We were there a week. 1 week, the problem never changed. And sometimes you really got to think about that stuff. You know, that is absolutely not an acceptable thing. And it's the type of thing that, you know, anybody should be able to point out, right? And you should be able to take action on it. I mean, it was a very serious problem. I think, Jim, would you agree?
Absolutely. And those are, they may look like little things, but they're actually pretty significant.
Absolutely. Excellent.
Okay.
Any more questions?
Yeah. Anyone have any questions? Feel free to go ahead and unmute. Morgan, just let you know, Jim had to hop off. So
Yeah, I've got to drop off. Sorry about that.
Okay. Thanks, Jim.
Take care.
does anyone have any questions before we close out? Okay, I don't think we have any more questions. So thanks to Morgan and to Jim for all the information that they gave today, and thanks everyone for attending as well. And don't forget, if you haven't already, if you're interested, EduCon, which is our fall conference that's coming up in a few weeks, registration is still open for that. We do have some working group meetings and some training courses that will be happening. It's going to be in suburban Chicago. So go ahead, you can find that information on the IEST website. But thanks everyone, and everyone have a good rest of their day. Thank you so much.
Thank you,
Thank you.
everybody. It's been a
Appreciate it.
pleasure.
Thank you. Bye.